So hello students, this is the fifth class of electromagnetic theory, and the topic today we are going to discuss is Fresnel equation. That means how the electromagnetic wave travel from one dielectric medium to another dielectric medium. Okay, today I am going to discuss only the perpendicular incidence case. Okay, that means if this is the let me change the color. If this is the boundary of a medium, then the wave is traveling perpendicular to this boundary. Okay, that means if this is the medium 1 and this is the medium 2, then the wave is propagating in this direction, not like this. This is not the case, this is the case. Okay, or maybe it may came from this side also, like this. Okay, the angle between them is 90°. So this is the perpendicular incidence case. Okay, here as you can see I have taken two medium. This is medium 1 and this is medium 2, and this is the boundary, right? As you can see, the wave is propagating in this direction, then some part of the wave got transmitted and some part of the wave got reflected. Okay, so the wave factor of incident wave is ki. That means this is the boundary and the wave is propagating in this direction, and this is called ki, wave factor of the incident wave. And then some of this wave got transmitted, this is kt, transmitted wave factor, right? And then some part of the wave got reflected, like this, in this way. So this is kr, wave factor of the reflected wave. So this is the case. This is ki incident, this is kt transmitted, and this is kr reflected. Ki is in this direction, that means the wave came like this way and then got transmitted towards this. This is kt, and then some part of it got transmitted. This is called kr. Okay, so this is the case. Now we need to specify some quantities of this medium. Okay, so let's say permeability of the medium 1 is mu1, permittivity of the medium 1 is epsilon 1, and then the refractive index of the medium 1 is n1, and the velocity of the wave in medium 1 is v1. Okay, so this is the case. And for medium 2, the corresponding terms are mu2, epsilon 2, n2, and v2. Okay, and then vi is velocity of the incident wave. Okay, and vr is the velocity of reflected wave, and vt is the velocity of transmitted wave. As you can see, the velocity of the wave in medium 1 is v1, and I have written here the velocity of the incident wave is vi and reflected wave is vr. As you can see, both these wave are in medium 1, so vi is equals to v1. Okay, let me write it down. Vi is equals to v1. Okay, in terms of magnitude only. Okay, and vr, reflected wave, velocity of reflected wave, this is also v1, but the direction of vi and vr, these are opposite. Okay, direction of vi and vr are opposite to each other. And now, since this is an electromagnetic wave, so there will be electric field and magnetic field associated with this wave. Okay, let me write down the electric field and magnetic field, okay, of this wave. So for incident wave, what I can write, the electric field of the wave is ei, and it is equals to eoi, some magnitude term, and then the exponential term. Okay, e to the power I kz minus omega t. And this axis is, as you can see, this axis is z axis, so the wave is traveling in the direction of z axis, so I can write it kz minus omega t. So this is for the incident wave. Okay, and since the wave is traveling in this is z equals to 0 point, right? This point is z equals to 0 point, and this is positive z axis. Okay, and this is negative z side. Okay, so since the wave is traveling in positive direction, so what I have written kz minus omega t. But if the wave is traveling in negative z direction, then what will happen? Kz plus omega t will be there. Okay, or if you take this as positive, okay, for the wave traveling in positive z direction, if you take this as positive kz plus omega t, then for reflected wave this will be minus kz, that means kz minus omega t. Okay, this will be negative. Okay, so only this sign will be get interchanged. Okay, and for transmitted wave, since it is again traveling in positive z direction, as you can see kt is in this direction, so what will be et is equals to eot, some magnitude term, and then e to the power ikz minus omega t. Again it is traveling in positive z direction. Okay, and what is eot? It can be complex also. Okay, these three terms can be complex also. These terms are magnitude terms. Okay, similarly for magnetic field also, what I can write, bi equals to, for incident wave, bi equals to boi e to the power ikz minus omega t. These terms are similar. Okay, just only this is b. Okay, instead of e we are writing b. Okay, for reflected wave, b equals to br equals to bor e to the power ikz plus omega t. Similar concept. If this is negative, this will be positive, and then bt is equals to bot and e to the power I kz minus omega t. Okay, and then so now to find a Fresnel equation, what we are going to do, we are going to use the third boundary condition and fourth boundary condition. Okay, these third and fourth boundary conditions are for what? For parallel electric field and parallel magnetic field. Okay, so from third boundary condition, what we have got? We have got E1 parallel equals to E2 parallel, right? This is the third boundary condition. As you can see, I have taught you this in the previous class. Let me show you. So parallel component of electric field and magnetic field, that is E1 parallel equals to E2 parallel, right? Similarly, what is fourth equation? If the both medium doesn't contain any surface current, then H1 parallel equals to H2 parallel. This was the fourth equation, right? So let us get started with it. Okay, so using the third boundary condition, what we can write, E1 parallel equals to E2 parallel, right? But as you can see, uh, there are two electric fields in medium 1. Okay, one is for the one is of the incident wave and one is of the reflected wave, and in medium 2 there is only one electric field which is of the transmitted wave. Okay, so these are in medium 1 and this is only in medium 2. So for E1, what we have to add, we have to add EOI and EOR. But as you can see, this is the parallel component, right? But how I have written here the whole electric field? Okay, we have to take only the parallel component, so let me write it down. Okay, actually I can write it down it here. Okay, so this is the boundary, right? So wave is traveling in this direction, right? This is the z direction. Okay, so in which direction electric field can be, since E, B and direction of propagation, here it is z. Okay, so all these three are perpendicular to each other. The electric field must be in x direction or y direction, because it have to be perpendicular to z direction, right? So what I can write, I can, let's say this is the x direction. Okay, and let's say this is the y direction. Okay, this is x, this is y, and this is z, right? Mm. So now the electric field is only in x direction, that means it is like this, like this, like this. Okay, electric field will oscillate in this medium, right, like this way. So electric field is in x direction and the boundary is like this, right? So what I can say, I can say the whole electric field is parallel to this boundary, right? only perpendicular direction is z direction, so the whole electric field is parallel to this boundary, right? And similarly, if magnetic field is oscillating in y direction, then what I can say, okay, and if the magnetic field is only in y direction, then what I can say, I can say that the magnetic field, the whole magnetic field is also parallel to this boundary, right? So here let's move forward. What I have written, for one first medium, this is for first medium, EOI plus EOR, and then for E2 only EOT is there, okay, right? So, and using the fourth condition, H1 parallel equals to H2 parallel. Remember that this boundary doesn't contain any surface charge, so it is only possible because of that we can write this, okay. There is no surface current. So what is H? H equals to, what I can write, H equals to B by mu, right? Again, what is B? B equals to E by C, C or V, as you can say, C or V. Let me write it down as V, V, and U is here. So H can be written as E by U V, right? So as you can see, what I can write, for incident wave, EOI divided by mu I Pi. Mu I is the permeability of the medium where the incident wave is there, and this is for reflected wave. This is EOR by mu R Phi R, right? Mu R is the permeability of the medium in which reflected wave is there, and this is the velocity of the reflected wave, right? And similarly, these are for transmitted wave, okay. And as you can see, mu I, that means the medium permeability of the medium in which incident wave is there. Incident wave is in medium 1, as you can see. This is medium 1, this is incident wave, right? So for mu I, what I can write, I can write it down mu 1 as the uh, incident wave is in medium 1, okay, and Vi can be replaced by V1, right? And then for reflected wave, mu r is also mu I, but Vr is minus V1, because as you can see, Vi was in this direction, Vi, but Vr was in this direction. So as you can see, these are opposite to each other. So what I can write, I have to add one negative sign, okay. So that's why there is one negative sign. And then this is for transmitted wave, it is in medium 2, so mu 2 V2, okay. So these two terms are common, right? So I can take this towards right, so this will be mu I minus mu r, then this term will be in the numerator, and in the denominator there will be mu 2 V2 and then EOT, okay. Let me consider this term as what? This term as beta. So what I can write, EOI minus EOR equals to beta, right? So this is the second equation. And what was the first equation? First equation was this equation, right? Okay, let me, okay, so this is the first equation, EOI plus EOR equals to EOT, okay. And then this is the second equation. Second equation is what? EOI minus EOR equals to beta EOT, okay. So this is the second equation. So here I have written down the first equation again. So this is the first equation. On adding these two equations, what we will get? This is EOI, this is EOI, and this is minus EOR, and this is plus EOR. So this and this will get cancelled, okay, right? This and this will get cancelled, and only 2 times of EOI will be in the left hand side. So 2 times EOI, and on the right hand side, what will be there? 1 plus beta EOT, right? So this is the term. So what I can write, EOT in terms of EOI, EOT equals to 2 divided by 1 plus beta EOI, right? This is the term. And then if I am going to subtract 2 from 1, then what I will get? Okay, if I am going to subtract this, then what I will get? This is EOT, I plus EOR minus EOI, and this will be plus. So this will be get cancelled, and this term will be there. So 2 times EOR and then 1 minus beta. Here the coefficient of EOT is 1 and here it is beta, and then 1 minus 2. So what I can get, 1 minus beta EOT, right? And how I can write EOT? Okay, as you can see from here, EOT is what? 2 times EOI divided by 1 plus beta, right? So replacing this here, okay, EOT equals to 2 divided by 1 plus beta into EOI, right? So, and this term will be here, and this is right there. Okay, so what I can write, I can write EOR in terms of EOI as these two will be, these two and these two will be get cancelled, right? So 1 by 1 minus beta divided by 1 plus beta into EOI. So this is EOR. So this equation 3 and 4, these are the Fresnel equation. Okay, so as you can see here, I have written equation 3 and equation 4 are called the Fresnel equation or Fresnel relation, right? So this is for normal incidence case. Okay, so this is for normal incidence case. There is the condition of oblique incidence also. I will tell you about it later. Okay, so but now what I will teach you, that there are two terms called reflectance and transmittance. Okay, as you know, if this is the incident wave, right? Okay, let me write it down here. This is the incident wave. Okay, so let's say it has some intensity I. Okay, and then some of its intensity will be in the transmitted wave, right? Let's say it is IT, right? And then some of its intensity will be what? Reflected. That means IR, as you can see. So I minus IR equals to, right, IT, because the whole intensity is because of the incident wave, and then the intensity of this incident wave is divided into transmitted wave and reflected wave. So IT and IR. So I equals to IT plus IR, as you can see. So uh, here we can show that the reflectance R and transmittance T equals to the summation of these two term equals to 1. Okay, so what we have to show, we have to show R plus T equals to 1, right? R plus T equals to 1. So now what is reflectance and what is transmittance? So for reflectance, R, it is reflected intensity divided by incident intensity. Okay, so IR divided by II, incident intensity, right? As you can see, here is the transmittance. Transmittance T is transmitted intensity divided by incident intensity, IT divided by II. Okay, now how we can write the intensity in terms of electric field? Okay, so in terms of electric field, I can write down the intensity as I equals to half of epsilon V and E, magnitude term. Okay, this square. Okay, so this is the intensity term. Okay, so intensity is equals to half of epsilon. Epsilon is the permittivity of the medium, and V is the velocity of the wave in that medium, and E is the magnitude of the electric field in that medium, right? So for incident wave, what I can write, I can write II equals to half of incident wave is in medium 1, so E1 V1 and then EOI square, right, magnitude square. Similarly for reflected wave, it is also in medium 1, so half of E1 V1, right, E1 V1 and EOR square, right, magnitude square. So for reflectance, what I will I have to do, I have to divide this IR by II, right? So for IR, half of epsilon 1 V1 EOR square, and then for II, that means intensity of the incident wave, half of epsilon 1 V1 EOI square, right? So these are same terms, so these two terms will got cancelled, only this will be there. Okay, again what I can write EOR in terms of EOI. So let me tell you here, we need the relationship between EOR and EOI, right? So from equation 4, as you can see, this is EOR equals to 1 minus beta divided by 1 plus beta EOI. So EOR divided by EOI will be equals to 1 minus beta, right? EOR divided by this term will be 1 minus beta divided by 1 plus beta, right? So here I have written it here, 1 minus beta divided by 1 plus beta, and since the square is there, this will be squared. Okay. Similarly for transmitted, as you can see, transmitted intensity divided by intensity, so IT divided by II. So similar term. Okay, epsilon 2 V2, since transmitted wave is in medium 2, so permittivity of the medium 2, and then the velocity of the wave in medium 2, and the electric field, right, EOT. So what is transmittance? So IT divided by II. So this is for IT, and for I, that means intensity of incident wave, we have got it here, right? So using these two, what I can write, this divided by this, right? But here these two terms are not same, right? So only these two will be got cancelled, and this two term will be here, and this is the square term, right? And EOT divided by EOI from third Fresnel equation. Okay, where it is, let me check. Okay, EOT divided by EOI, this term divided by this term. Okay, so here will be 2 divided by 1 plus beta, right? So 2 divided by 1 plus beta, so this is the term, this is whole square, since there is a square term, right? And now I am going to simplify these two term, epsilon 2 V2 divided by epsilon 1 V1. Okay, so now what I am going to do, as you can see in this term, okay, in this term I am going to multiply both the denominator and numerator by mu1 mu2 divided and okay. So in this term, what I am going to do, I am going to multiply the both numerator and denominator by mu1 mu2. Okay, so let's multiply it, epsilon 2 v2 into mu1 mu2, similarly epsilon 1 mu1 epsilon 1 v1 into mu1 mu2, right? Now here is one thing. Okay, in the first class what I have told you that mu1, sorry, not 1, mu epsilon, it has the dimension of velocity square, right? 1 by mu1 epsilon 1. So this is equals to what? Velocity square, right? If the velocity of the wave is c, then this is velocity square, that means c square, right? But now as you can see, here is what? Epsilon 1, I am going to use this. Okay, epsilon 1 mu1, then what will happen? Then 1 by, there will be the velocity square, right? But here the velocity is 1 v1, so epsilon 1 mu1 equals to 1 by v1 square. Similarly epsilon 2 v2 equals to 1 by v2 square, right? So I am going to use these two relation here. Okay, so as you can see, I have uh, taken these two term. Okay, epsilon 2 and mu 2, these two term, and these two term v2 and mu1, these two term are remain as it is. Okay, mu1 v2, right? So as you can see, epsilon 2 mu2, this will be what? 1 by v2 square from here, so I have written it 1 by v2 square. Okay, and similarly in the denominator I have taken these two term, epsilon 1 and mu1, and these two term are as it is. Okay, so as you can see, epsilon 1 mu1 equals to 1 by v1 square, so this is 1 by v1 square, and here is v1 and here is what? v1 square, so only 1 v1 will be there. This and this got cancelled, this and this got cancelled, and this v1 will be now moved to the numerator and this v2 will be in the denominator. Okay, so what will happen, this will be mu1 v1 and mu2 v2, right? Again we have considered mu1 v1 by mu2 v2 as beta, as you can see it here. Here. Okay, mu1 v1 by mu2 v2 equals to beta, right? So this is again beta, so I am going to replace this term by beta now. Okay, so t equals to what, beta into 2 divided by 1 plus beta whole square. Again 2 will be what, 4 beta, like 4 beta divided by 1 plus beta square. Now what I have to show, that r plus t equals to 1, that means reflectance plus transmittance equals to 1. So now let add these two terms. This is what, this is reflectance, r equals to 1 minus beta divided by 1 plus beta whole square. So this is the term 1 minus beta divided by 1 plus beta whole square, and transmittance is 4 beta divided by 1 plus beta whole square, right? So this is r plus, so this is like a minus b whole square plus 4ab, so this will be a plus b whole square, so 1 plus beta whole square, and in the denominator there is also 1 plus beta whole square, so 1 plus beta whole square, 1 plus beta whole square, so this will be equals to 1, so r plus t equals to 1. So this is the proof that r plus t equals to 1, that means the reflectance and transmittance, their sum is 1. Okay, right? So this is the proof. So that's all for today, and then in the next class what we will do, we will uh, the we will consider the case of oblique incidence. Okay, so thank you.